I first met Dr. Yap when I took her Calculus 2 class during my first quarter at Cal State East Bay. I immediately noticed that there was something different about her teaching style. Instead of just standing in front of the class and regurgitating the textbook, she promoted a more active style of learning. When presented with a problem, she encouraged us to try to visualize and understand it first, and then try to come up with our own intuition on how to solve it. If we were struggling, she would suggest some different approaches to try or some resources to use. She never just gave us the answer outright, which was frustrating when I was struggling to find the answer, but was really satisfying when I finally did, and it made me feel like I was really learning, and not just memorizing formulas and definitions. Dr. Yap also had us complete a project in the class, where we had to implement an application of calculus. One of the other students used 3D modeling software and a 3D printer to show us how calculus could be used to create a physical model. This is just one of the many ways that Dr. Yap showed us that calculus is useful for more than just computations. I had learned so much from Dr. Yap that quarter that when she told me she was offering a mathematical modeling class, I didn't hesitate to sign up, even though I had no idea what the class was about and I wasn't even a math major yet. I just knew that I wanted to learn more and that Dr. Yap would be able to help me. It was after this class that I realized how much I enjoyed learning about math concepts, so I decided to add math as a second major in addition to computer science. The modeling class was different from any other class I've ever had. Dr. Yap went out of her way to partner with companies in industry to give us real industry problems for us to solve in groups. My particular problem came from Dr. Marty Betts at First Rain, a data mining company, and it had to do with natural language processing and neural networks, both complex concepts that I knew nothing about. Dr. Yap encouraged us to research the material, try to understand the problem, and look for possible solutions on our own. Instead of lecturing during class time, we were given the time to collaborate with our group or consult Dr. Yap for her insight. At the end of the quarter, we were to present our work to the industrial sponsors. Working on a real world problem gave me a sense of purpose while I was learning. I knew why I was reading those research articles. It wasn't to solve some hypothetical problem that the professor already knew the answer to. It was to solve a problem that people were actually working on in the workforce. After the modeling class ended, Dr. Yap continued to work with me on the research project, researching a particular type of optimization problem, and it's really the first time that calculus felt useful. We are measuring growth and rate, not just abstractly, but for a very important application. I presented my research at local and national math conferences, which helped me understand much more about mathematics outside of the classroom.